Manufacturing companies across the world are using RFID to achieve major benefits, both in their supply chains and in their factory operations. Our speakers today will discuss how to use RFID and other IoT technologies to achieve a variety of benefits, and they'll discuss some of the issues that you need to be aware of if you want to use RFID in a factory setting. So now I'm very pleased to introduce our first speaker. He is Edna Broadsky. As I mentioned, he's Chief Solutions Officer for Omni-ID.
All right.
Okay, you should have control now.
Thank you, Mark. I'll see if I can click and make this advance. But I appreciate the introduction, and this is such an important topic. We're glad everyone could take some time to discuss it with us today. Manufacturing is close to the heart of Omni-ID. We focus on this sector very much. In my own personal career, I've spent a lot of time in the manufacturing sector, and I've also run a couple of plants as a plant manager. So the issues we're going to talk about today are not theoretical. They're real, and we see them every day with our customers and with our experience. So to start with, there are 550 million returnable containers cycling daily around the world. That's a rough number, but this is what the studies tell us as we look at and count what's in all of our global manufacturing space. That is a lot of containers, and a lot of effort is put into the logistics and supply chain, getting those containers to the plant, and also managing those containers. It's been a traditional place where RFID is attacked for tracking. But there's a gap that we would like to talk about today more specifically with those containers, and is a big target of Omni-ID, managing those containers when they're on the factory floor. A new trend that we see emerging is the complexity in manufacturing. It's been building for a while, but the IoT world that we live in now is making this even more pervasive. Many of our customers and large manufacturing companies have the vision that their customers can be sitting on a couch at home with a smartphone and order a variation of a complex device, even up to an automobile or an appliance, and have it customized exactly how they want it. And when that demand trigger comes from that smartphone through the internet, it can immediately hit the plant, and the plant can be making your product just the way you wanted it, exactly the way you've ordered it. And literally, you might even be able to track it and see it in its production, see when its delivery is going to happen, and get updates on your product. Some of our more advanced car companies are starting to move down this path, and certainly many consumer devices are moving down this path as well. For a plant manager, that creates a complexity that's been unheard of before. Gone are the days when you build a factory that does one thing on one manufacturing line and does it over and over and over again. We're gone from that mass production model. We're now in a mass customization model. And the complexity that drives all the way through the supply chain, bringing materials to the line, is tremendous. And paper labels just can't keep up. They're far too rigid and far too ballistic in their application, and they don't adapt well to these constant demand triggers that are now coming across the internet and increasingly will do for these plant managers. Specifically, when you look at a plant floor, most enterprises have a very good system for their parts warehouse where parts come in from supply chain, and there's some very sophisticated logistics providers and systems to bring those parts there. And they're very good at the shipping dock where we have goods coming out and have to be delivered with the delivery systems. But the real issue that they're facing is, what am I doing in between those two places? Most factories, most manufacturing enterprises have very little visibility to what's happening in their work-in-process inventories. They have inventory all over the floor in various stages of assembly, some of it well-sequenced, some of it balanced, but many times not. Many of it using the Kanban systems from the 70s to try and roughly approximate demand triggers in a system. And we believe and are seeing with our customers that that paper is really becoming outdated and doesn't give the visibility required in an IoT world. So we had designed a new system called Proview to address that WIP gap. Proview stands for Process View. It's intended to give you a window into the plant and give you a chance to see that work-in-process inventory and the assembly pieces. But more than that, it also is a view for your operators who are working in that process to view what they need to do next and to give guidance. This is truly an IoT technology. It's a different paradigm than we've had in the past. Instead of having paper labels that are slapped on at the beginning of the process and guide the worker to follow a rigid path, these are now smart tags that can tell operators what to do. Literally mounted on a container saying, paint me blue or take me line side. Operators can execute instructions and interact with the system. This is a really important part of an IoT paradigm, that it's not just a rigid follow one path, but that we can manage the complexity through human choices and giving operators some ability to alter the course of events without losing control of the system. Much like all RFID technologies, and this one clearly is an RFID technology, we can track those actions, and software and tags can store the analytic data that can be very, very rich from this process. It allows us to locate things, put quality holes, and be able to count things by state and condition where it is on the floor. This is a fundamental new paradigm and different way of thinking when you think about a smart container moving through your factory on a path. One way to think about it that often resonates as people think about this paradigm is think about your smartphone you've become so used to. Imagine if that phone could only make outgoing calls, or when you're browsing on the internet, make outgoing orders, but you couldn't get any confirmations back or any messages back from that order you just placed or that call you just sent. How crippled would that system be? How in the dark would you be about what to do next, especially if there was vital information to tell you? IoT means bidirectional, and placing a smart tag or a smart label that's trackable gives you all the benefits of RFID, which is that I could track and monitor what's going on, but a factory needs to be more than just watched and measured. It needs to be interacted with, and messages from the system have to come down to the operators, just like on your smartphone, to tell them what to do next. Another way to think about it is a GPS system. Your GPS can suggest the route that you should go, but sometimes things happen. You have to get around roadworks, or you take a different route because you know that you've had experience in the city that you have to get around something that's a problem. And the GPS recalculates and gives you a new optimal path based on a choice you made. This IoT paradigm does exactly the same thing. If you see a queue coming up at a machine and you know there's another machine center that's going to be free, as you take that smart box over there, it recalculates, realizes you've made a decision, and the system accommodates that, and the label changes dynamically before your eyes, telling you now where it's going to go and what the action is that has to happen. This new paradigm of interactive, trackable, visual tagging will fundamentally change the way process flow happens in the factory floor, much like Kanban did in 1970 when the Japanese production methods came over. And it's very, very much a convergence of common technologies today. So as we think about it in a plant and we think about different areas, think now about, instead of the chaos of boxes and containers going everywhere, sometimes with predetermined routes, sometimes with local worker knowledge, we have the ability to track and send messages to each of those boxes to tell them what needs to happen. We remove latency and extra inventory from the system because now we can balance it dynamically and see exactly what's happening. If we have a different demand trigger that comes into the factory to make a different kind of part, or more commonly, a different variation of the part. So today I have more demand for a particular color, and I've got to do more blue left-hand mirrors for my car, I can adjust my inventories and systems automatically, and that reduces my inventory and my holding costs. If I have a quality hold that needs to be put on because I see something at one part of the process, rather than send humans with red tags all through my plant, I can have the system automatically change those labels to say that they're on quarantine or they need to be redispositioned for inspection. The opportunity for improvement is endless when you start thinking about your containers as IoT devices, as smart boxes that can now know where they are in space, know what the next step in the recipe is, and be able to talk to the operators through operator-readable instructions to tell them what to do next. Tremendous savings and a whole new way of thinking. So what is Proview? Proview is a complete solution. It is services and consulting. We have a number of experts that can work with you from our channel partners as well as from Omni-ID that can help you understand how to use this new paradigm. Quite often when you are used to doing something one way, it's hard to think of anything but paving the cow paths. You know, I can use this smart visual tag as a replacement for paper, and that's true, you can, and it can be very cost effective just for that. But having someone to help you understand how it can change your process, to take out latency, to reduce your inventories, to improve your quality process and quality inspections, can really help you think about your process in a different way. And I think you'll be astounded at the savings you can achieve using that system. There are some off-the-shelf pieces of software that assist in this, things like replenishment, things like work instructions, whip tracking, quality modules. But what's really important in the system is that it is an open system. Omni-ID is very committed to open architectures and using open standards. And so if you have existing software that you're using today, or if there's a channel partner or system integrator that you're already working with a very simple modification, we can usually hook up to their software and be able to have them drive the Proview system. And of course, asset tracking hardware. Omni-ID is a leader in harsh environment tags of all different types, everything from passive to active and now visual that's been added to our lineup. It's important to note that not all containers need to be visually tagged. They can be tagged with RFID tags, traditional passive and active RFID tags. And Proview accommodates all of that, including barcodes, to make a system that can be a hybrid of all those different technologies. So to us, Proview is a complete process view, a visual solution that is an IoT solution for your plant floor. Driving that, though, is some innovative new hardware. Omni-ID has led the market in bringing what we call visual tags to market. What's a visual tag? Well, a visual tag is really a fusion or a convergence of several technologies. It starts with the e-paper that drives that operator interaction. We use electrophoretic e-paper, very similar to a Kindle that you may have seen many years ago and still out there in the marketplace. It's persistent without power, which is really important. This means that it only draws power when you change the image. Having that gives you a couple of different things. One, if you have a fear that if the batteries run out, you're going to lose your information, you don't need to worry about that with e-paper. You can pull the battery out of these devices or run over them with a forklift, and that image will stay there just like a paper label would. So there's really no additional process risk by going to a visual tag from a paper label. They function the same because of the e-paper. But very importantly, it gives you extended battery life. We're able to get 5 years of battery life on a tag like the small label tags that you see, the V3 and V4, or in the V10's case where it's being operated almost continuously with many push buttons and operator interaction for its typical use case, we recharge it about every 2 weeks. These extended battery lives are really important and differentiated it from an off-the-shelf product, like a tablet, for instance, or using some kind of LCD display. It has an active radio and a passive element, and this is another important technology piece in that passive and active combined together give you some very interesting capabilities. This is probably not the forum to talk about that in a lot of detail, but the ability to turn things on and configure it with passive, and also the ability that even if something goes wrong in the active radio, to still be able to track your goods with passive is a really important feature here. It also allows us to have hybrid systems where your passive infrastructure, such as portals, can also read these visual tags the same way as they can any other passive tag. So a visual tag is an interesting hybrid that allows you to do a lot of different things. Each visual tag from Omni-ID also has a push button on it. This enables operators to interact with the system, to confirm an action, to call for parts, to stop the line, to put a quality hold. That button can mean different things. And what's interesting, because you have the ability to change the image on the page, it's a soft key. In other words, if you put an instruction on the page that says press button to confirm that you've completed your assembly step, that's what that button will mean when you're on that page. And the signal to the system says I had a button push event on page 3. And in a lookup table in the logic, it tells the system that means he completed his assembly action. So it's a tremendously flexible system for operator interaction, again, all driven by the visual element. And the visual element is key for interacting with your workers. Omni-ID, of course, makes many other industrial RFID products, so Proview isn't just about visual tagging. The advantage in using a hybrid approach is that different containers might be more effectively labeled with, for instance, an on-metal IQ label. Or perhaps it might be the tools running from your tool shop, and you might need a small fit tag, a small ceramic tag that could be embedded directly in your tool. Or perhaps it needs some specialty tag, like the Adept 360 that's shown in this picture, that could be hanging on a sling or a shackle or a chain. Perhaps it's your delivery vehicles that need an active RFID tag so that they can be tracked widely in space to know where your route drivers are at any given time in their delivery schedule. Using a broad range of different tagging technologies, but all treeing up to the same Proview software, you get a complete view to your factory floor, not leaving any gaps in your process and being able to balance your inventories and your workflows. So let's talk about some applications. I hope that the previous slides have given you some introduction to what's possible. Let's talk about practically what's being done right now, and perhaps that will stimulate some additional ideas for people in the audience that are thinking about, now, how can I use this new IoT paradigm in my plant? There have been 4 applications that we've typically focused on here at Omni-ID. trying to solve their problems specifically. So one is work instructions. Work instructions is typical paper sheets or travelers that are in many manufacturing plants. I know the plant I used to run, we had a paper sheet that traveled with every bin of goods, giving the workers instructions on how to assemble parts. So work instructions is quite common. WIP inventory, which is a bit of a catch-all. This is typically goods that are transformed through several steps, what we call a recipe. And in that recipe, they'll travel in a rack where they might be first stamped, or they might be painted, and then they might be have attachments put onto them. As they go through those different steps, that WIP inventory changes status, sometimes changes counts, and we care a lot about how much we have of each thing and where it is. So WIP inventory is a big application area. Replenishment, which is about getting things to the line effectively out of your parts warehouse and to where it can be assembled. That's another huge application for us. And asset tracking, which is a general term for tracking assets generally in space, whether they are in a yard or in the factory itself, and is more typical of small parts and sub-assemblies. So let's talk about the first one, work instructions. So how does this work? So today in many plants, you will have a printer by your line where you'll print out job sheets, work instructions. In some cases, many, many pages for one particular thing that's being built. If it's a car, we typically see somewhere between 5 and 8 sheets of 11 by 17 paper telling workers how to assemble the different stages of that car. If it's something more complex, like a large oil and gas valve or an appliance that has some different features to it, the build books can be quite large. They can be up to 50, 60, 70 pages. Engine blocks typically in that range too. So there's a lot of paper being printed to go with each one. Typically they travel along, as I mentioned, as a traveler with the asset, and as it comes to each station, perhaps it's a welding station, perhaps it's a painting station, the worker flips to the appropriate page and completes the action, often tearing off the sheet and putting it in a bin beside the line, represented by the paper you see at the bottom. That traditional system is very paper intensive. The other challenge with it is it's not really trackable. That piece of paper typically isn't tracked through the process, so you're not sure at any given time where a given job is on the line. The other problem we have is that there's often annotations. Quality inspectors or workers will annotate to say that they did something a little bit differently. Maybe it was out of tolerance and they added a wedge that was 1 millimeter larger, or a quality inspector will ask for a different borehole to adjust it, and it might even be pulled out of process to do that. We've seen cases where people scrawl with crayons on these worksheets or put quality markups on that are never really captured. Once the assembly's done, those sheets are thrown away like all the other paper, and you're never sure what the as-built record is. So with a visual tag, you can now attach the visual tag to the asset, and you gain some immediate advantages. As with all RFID, you can now track that asset. You can see where it is in space. But in addition to seeing where it is in space, you can now see what status it has. Because as the visual tag advances through the pages, which in effect is advancing it through the process recipe, you can know at what step the asset is. It's been painted. It's been assembled. It's had hoses put onto it. And that way you get an immediate dynamic count of your inventory in various stages. If you're like Volkswagen, for instance, where they're now committing very much to building common platforms and using their many, many models to consolidate their parts, you might be able to redisposition something partway through, the ultimate in flexibility. So a sub-assembly might be made for a Jetta right now, but suddenly you shift demand to something else, and that could be reused to somewhere where you're short on inventory because it's only gone through the first part of the recipe and it's still applicable to 4 models instead of 1. We're seeing more and more manufacturers talk to us about common platform parts like that, and paper, again, can't keep up to that kind of a change on the demand cycle. As workers do their part, now instead of marking up the page with a piece of a pencil or a crayon, they press a button. And that button press updates its status and also confirms or digitally signs that that action's been done by that worker at that time. It also captures a timestamp. And that analytics data is much richer than anything you get from paper. It enables process designers to look at the process and see what latencies they have between stations, and perhaps even monitor workers or look at productivity measures to help workers in the steps that they're doing to balance the line. At the end of that production, sometimes there might be a QA check. And having a trackable visual tag allows you to pull the product right out of the line and do your QA step, have the QA person annotate and mark it up in the visual tag so it's captured electronically, but also allow you to see what's been pulled out for QA and see the timing on that. If there's an issue later in the field and a complaint came in, you can check your document database and your as-built records, and you can see exactly who worked on it and which quality inspector pulled it out at what time and what actions were performed on it in a way that is far superior to paper and attempting to retain those records. So work instructions is a core application for us, and there's a lot of benefits. Obviously, the savings of the paper is the first thing that our customers look at. But once you get beyond the paper and you think about the advantages of the real-time analytic data you gather, the confirmation steps from the workers, the ability to interact with the system, there's a lot of extra benefits to work instructions using visual tagging. A concrete customer that implemented this is Detroit Diesel. They're a Daimler Corporation company. They make engines for the large Freightliner trucks. An engine assembly is a very complex assembly. It has a lot of different little parts and pieces that are attached to the engine block. What happens in their case is they have an AGV, or an automated guided vehicle, that the engine block is mounted onto. And as that AGV goes through the plant, workers attach various components to that core block. The AGV will spin and rotate the block so that the worker at each station can put their particular piece on and perhaps do some testing. In order to accomplish that, they have a build book that can be anywhere from 50 to 60 pages of paper, 8.5 by 11. You can see on the AGV picture on the right-hand side where that build book gets slid into a small plastic envelope, and as it gets to each station, the worker pulls out that book, looks at their relevant page, perhaps marks it up, things that they're doing, and then puts it back in again. And Daimler was looking for a way to replace that. That build book was very expensive. It wasn't trackable. Quite often there were markups, as we mentioned, because building this engine is so precise, and the fuel economy and the reliability is so crucial for their customers. They wanted to capture all the small changes or things that are noticed by the technician in assembly, and the paper just wasn't able to keep up to that. And so you see the picture at the bottom right with one of the visual tags, the 10-inch visual tag, substituting the build book. They've completely converted over to that process now, and the build book drives the production, enabling the savings and all the tracking that they're looking for. Now we have infrared triggers that are mounted at each of the workstations. The infrared triggers emit a code, and in this case, the visual tags can either receive signals through their RF, through their passive RFID, or through button pushes, or in this case, infrared beacons. Now that allows them to be smart and know the action that's acting on them or the location that they're in. In this case, the infrared beacons were able to beacon a code at each workstation, so as the workbook goes to that station, it receives the code and it knows I'm now at welding. And the system is updated to say it's at welding, and the device automatically flips to the welding page with welding instructions. It's a great benefit and much faster and more effective than paper. We have other customers that will also put procedural instructions. So how do I change a tool if the tool breaks? If I'm a temporary worker on the line, I need to maybe press button number 3, and it flips over to the work instructions page that tells me actually how to do the assembly as well, where I might not use that if I'm a seasoned technician. It eliminates the kind of binders that you see sometimes line side or instruction cards that people would pull if they're bringing in a lot of temporary or flexible workforce. It's a great benefit for process steps like that. But Daimler continues to expand this system, and we have another second phase of this program going in this quarter. So one of our customer advocates at Daimler, an IT manager at their site, Robert Hayden, has spoken about this frequently. This IoT solution, what it does to track materials and control process flows. It really is gaining rave reviews, and if you haven't thought about using this for work instructions, I hope the presentation today makes you think about your process if you have paper travelers or need to give dynamic instructions to your workers. Another application, of course, which is really central to Proview's mission, is WIP inventory and routing. WIP inventory is a huge black hole for many plants. We print Kanban labels, we print stickers, and we assume jobs on the floor are getting done. And sometimes that assumption is wrong. I many times as a plant manager needed to have something on the 4 o'clock truck, and I had to walk out on the floor and go see where it was to make sure it would make the 4 o'clock truck because I had no other visibility to it. Often I'll find it might have had a problem because the machine was down for maintenance, or a worker didn't show up that day and there was a temporary worker, so productivity was lower on the cell and I wasn't going to make the 4 o'clock truck. And I was constantly seeking to have better systems. How could I know where my WIP was, and how could I redirect it if I had the inevitable problems on the plant floor that slowed down a particular job? So for WIP, putting a visual tag allows us to right away, and usually on the container, means that that container gets dispositioned to a job. So instead of walking out and putting a paper work instruction on a container or sticking it inside the bin, that tag will right away say the first step of the recipe. This job is job number so-and-so, and you need to take me over to paint to go get painted. And as the forklift driver drives that rack over to paint, the visual tag gets some of the beacon information either through the RF or the infrared to tell him he's got to the paint shop. That allows us to record that that's now in the paint room. But more importantly, now it flips the instruction. And now the guy in the paint shop looks at the rack and the message has changed and it says, paint me blue. That gives him real-time information of what to do at his work step. It may also say, press the button when you're done. And you might press the button on that rack to indicate that you're complete. In this case, we were doing white washer lids at the Whirlpool Corporation. And you can see the steps that we had in their case, where we had to commission the rack, load it with the appropriate parts, move it through several pieces of finishing, and then take it to assembly, where it would be assembled into its final product, and then replenish the line. So each process step may have different steps, whether it's 3 or 5 or 9 or 10 steps, but the key is the same. The visual tag is trackable, so you can know where it is. It's operator readable, so the operators know exactly what they're supposed to do. And it's dynamic, so that you can adjust. If something goes wrong, you can give new instructions to that WIP to route it to a different place or to signal a worker to do something different. And that's the key to this application. As we mentioned, Whirlpool is one of our early adopters of this and have spoken out about it and what it's done for them in their plant floor. It enables the ability to count, which is a big piece of this. In order to balance production, many companies, and Whirlpool is one, that would manually do a lot of counts to understand how many lids do I have? Do I have enough for the line for tomorrow? Do I have enough of the right type? You can imagine how difficult and expensive it was to do those counts at the end of every shift because it's a large plant. But more than it's a large plant, they have 32 different part numbers of white washer lids. I don't know about you, but when I'm looking at those white washer lids, I can hardly tell the difference. They might have a slightly different bend in the corner. They might have a different screw hole in one place. Sometimes it's just a different brand because they're making 4 or 5 different brands of the exact same type and have a different brand badge or depression for a brand badge. So counts are frequently off, partly because workers may miscount what type of product it is that's in the rack. So with Whirlpool, we were able to increase that accuracy, obviously the speed of it, so we didn't have any manual counting, as well as some really interesting benefits on the quality side. Being able to put parts holds on immediately and locate parts holds for inspection was a significant benefit here for their application. Brad St. Louis, who we worked with as an advocate of that system, has also been pretty public in talking about what he was able to achieve. Really the big benefit here was their real-time inventory, their counts, being able to know exactly how much was in each rack of each type, and allowed them to lean down their inventory, resulting in substantial savings. Knowing where the parts are and being able to balance the line is a big, big piece of WIP management. So, running to the end of my time, I wanted to just quickly conclude to talk a little bit about Omni-ID. Again, remembering who we are, we're the #1 manufacturer and supplier of industrial UHF RFID tags. We've had many first-to-market innovations, but really we have been a major leader in the on-metal market, doing a lot of harsh environment designs for on and in-metal tagging. Also, of course, we've done our first global frequency response ceramic tags, and we're the only ones now doing these hybrid e-paper visual tags that we talked so much about today. So a very innovative company with a lot of first-to-market accomplishments and many awards that back that up. We are a trusted global partner. We are truly global in our operations. Our headquarters are here in Rochester, but we also have a major design center in England with sales offices in Central Europe, another office in Mumbai where we do both some software as well as our local in-country sales, and then our factory in Qingyao, China, and our sales office in Shanghai to service that local market. So for our multinational customers, we have dedicated Omni-ID support all over the world and a broad array of partners, a very large channel in all those regions to support and do projects. I'm really proud of many of our partners and the way we've been able to work on some of these programs we talked about today. With that, I'll leave it open for some questions. I'm not sure, Mark, if we're going to do questions now or at the end.
No, we're going to do them now.
Okay, great.
Thanks, Ed. Okay, folks, if you have a question, click on the triangle next to the word questions in your tool palette, type in your questions, and those will be queued up for me to present to Ed. First question is the passive fit tag states high temperature. What is the maximum temperature these tags can operate within?
225 degrees Celsius is our classic high temperature tag. We do have some tags that are what I'll call mid-range high temperature that are going up in the 150 to 180 range, but our top-of-the-line high temp is 225 C.
Okay. Ed, very interesting webinar. Thanks. Do you see limitations to these applications in certain sectors whereby there is not the complexity components of automotive, aerospace, and electronics?
That's a great question. I was at a plant actually yesterday, and they were looking at all these great things, and they said the same thing to me. They said, Ed, we're simple. You know, all we want to do is replace the paper labels. We hate the paper labels. We hate the printing we have to do. We hate servicing the printers and throwing away all that paper afterwards. And we did an ROI calculation with him, and he had an 11-month payback just for replacing the paper and getting some of the traceability that went with that. Really simple calculation. So my answer, I guess, is yes. From healthcare to entertainment to manufacturing, if you just get rid of the paper labels in your cyclic count, you can probably pay for the system in a short period of time.
Okay. Do you have any electronic manufacturers using the Proview system?
Yes, we do. In fact, there's two real major initiatives we have. One is in semiconductor, where we're actually working in semiconductor fabs with what we call FOUP trays, or universal front opening pod trays. There's a real good application there. But we have two different SMT customers doing surface mount assembly and using the Proview system to do the surface mount assembly of electronic products.
Okay. We are just about to conduct a facility and IT readiness assessment. How important would it be to include a tag manufacturer at this stage?
Oh, that's a great question. To me and to the sales force that I work with, selling has changed a lot. It's not about a hard push for a particular product. I like to call it insight selling. And a lot of it is about being with your customer when you're doing that kind of a readiness review and provide insights or learnings that we have. Realize that Omni-ID works with thousands of different manufacturers every single year, and so we get something of a view of best practices. So I would highly recommend you get in touch with your local Omni-ID key account manager or sales office or one of our trained, certified partners that can show you some best practices, give you little insights as you go through that audit. It can only help, and you may discover some real gems of insight that would take your process to a new level.
Ed, do you find that there's any innovative ways that your customers are using the Proview system that was maybe unexpected?
Yes, we had a lot of interesting surprises. The HDK is open, and so they're able to send commands at whatever way they want to. One really interesting one was we have a large fulfillment house that rather than have the workers go to the assets or have the assets travel directly to a work center, they have a lot of movable shelving and work centers that actually move in space throughout the plant. And they were using it in a really innovative way, triggering the tags almost by the worker presence versus the other way around, the goods coming to the worker. That one was kind of an interesting surprise to me. But we've had others, that are doing sortation, for instance, that surprised me in the way that they would pre-trigger and record. So there's lots of surprises. I guess I could go another hour and tell you about interesting little ways we're using it.
Okay. In a nutshell, which steps are necessary to run a trial project for asset tracking with RFID? What is more important, tag functionality, software, or software functionality?
That's another good question. I may be biased because we're a tag manufacturer, but most of these projects start with thinking about what do I have to do, where do I have to read these things, and trying to get the right tag that can read at the distance that I want, at the price point that I need, and that'll survive the environment that it has to survive in. I think that's a really important place to start, because if you can't get that, you can't get the cost that you need out of your project, and you can't get the performance you're looking for. So I think it starts with, can I tag the items I need to tag with the right effective tag? After that, I think that the software system comes into play very strongly, understanding how it's going to tie into your business system. But as we often say, software is just typing in time, so you can overcome that with the right amount of money and time. If you can't tag and get the performance you need, you can't overcome that. The physics don't change. So you start there.
Okay. Last question. In our shop floor, there's a lot of metal. Would it be a risk for using these tags and getting them to work properly?
Yeah, it's always a risk. Metal, no matter what RF, can be a challenge. But those that maybe have tried RFID in the past, you'll be amazed at how much better we are around metal now. The structures are so much better, the technology is so much more stable, that perhaps an application in the past that didn't work for you probably does now. So if you've got a lot of metal, don't be discouraged. It can definitely work. We've done highly metallic installations where the tag's almost completely enclosed with boxes and metal parts, and it still works. But it does mean you need an expert to have a little closer look at it, and definitely test to make sure that it can work.
Okay. Ed, thank you very much for your presentation and for your support of this event.
Thank you, Mark.